Hey everyone, and welcome to another episode of Delusional Motorsports. In this episode, we're going to be building this chassis table. Let's get into it. Now, I'll be the first to admit that this chassis table is extreme overkill. It's built at a 4x7 by quarter inch box section, and quite frankly, if you're going to build a chassis table, you don't need anything near this heavy. I use this box section for 3 reasons. First, I knew it wasn't going to deflect under the chassis' weight. Second, I knew it would remain flat when I go to weld the chassis up. And third, I got a hell of a deal on it.
Using this box section comes with 2 major drawbacks. First, it's heavy. It's way too heavy. But hey, it was pennies on the dollar, so I couldn't pass it up. And second, these lengths aren't actually long enough for JoJo's wheelbase. I'm gonna have to weld 2 lengths end to end, and making sure these things stay straight on a garage floor is no easy feat, so I had to get creative. I'm using 2 half cuts as sawhorses, then stacking my uncut steel directly underneath and behind the joint to form 2 solid reference faces. Which brings us to the clamping situation. But before we continue, dance break.
Now, I know that this might all seem a bit overkill. I mean, we have our beam clamped to a beam behind it via these 4 clamps here, and we have another 4 clamps clamping the beam to a beam below it. The reason for so many clamps is when we go to weld our seams here, this beam is going to want to pull like no other. Once we go to weld this top seam, it's going to want to pull the ends up. Hence, I have the 2 clamps on the end. And when I go to weld this seam in front, it's going to want to pull this beam forward. Hence, I have the beam or the clamps on either end. I want the beam to cool in this position so that it is as straight as possible and prevent any warping due to welding. Now, whether this will work or not, I still don't know. So, hopefully it does, and keep our fingers crossed. So, let's get this welded up. Now that we've given this weld sufficient time to cool, let's see how we did. Hopefully this thing is still straight.
I have to knock down these welds so when I flip over the rail, it can lay flat against our reference beams. Now, let's pull the string line and see how our clamping jig held up against all that heat. Nice.
Well, you can see that the seam isn't perfect, but given the length of this beam, it's actually mad decent. Looks like I have at most a millimeter of bow, but that could probably come out as soon as I weld the other side. Now that the beam is welded all the way around and ground down, I took the same string line to check if it's straight, and like I said before, it looks mad decent. Next we have to do is the next rail.
To prep the next rail, I have to bevel all 4 sides of the joint on both beams. Because this is 1/4 inch thick box section, I'm grinding down to roughly 75% of the total thickness. This ensures deep weld penetration, so there's absolutely no risk of the table failing under load. Once the prep is done, I can give it the clamps! Now I can weld this side of the beam. Tickle it lightly with the grinder. Flip and repeat. But it wasn't all good news. This second beam is warped. You can see right here how it's rocking on the reference beam below it. The clamps failed me on this one. But no worries, fabricators use heat to destroy things, but we can also use it to fix them. I'm gonna flip the rail over and run a bead across the offending face. The heat from the weld should pull this rail right back to straight. And it worked like a charm. The heat did exactly what it was supposed to do, pulling the warp right out of the beam. Now that both rails are straight, I can finally move on to cutting the cross beams and trimming the main rails down to length. To keep this heavy stock from bowing downwards, I'm sliding a few cross beams under the drop to support the weight. No binding, no kickback. By the way, I've made every single cut in this 1/4 inch box using a Diablo Steel Demon blade on my standard 7 1/4 skill saw. This combination absolutely eats metal like nobody's business. You don't need a massive horizontal bandsaw or an expensive cold cut saw to cut thick stock. You can get this done easily with tools you likely already have in your garage. If you want to pick up one of these blades for your own shop, I'll throw a link in the description below. Now I'm setting up the first rail with the first cross beam. The clamps come into play yet again to lock everything in place. I check it for square, and while it's not perfectly dead on, it's close enough to tack. To make sure the other side matches exactly, I stack the second rail and crossbeam right on top of the assembly I just tacked. A few quick clamps, a couple of love taps with a hammer, and I tack this one together too. Now these assemblies are too heavy to pick up and manhandle. To save my back, I'm using the bottom piece as a pivot, and by grabbing the short end of the top rail, I can swing the whole structure around without carrying the full weight. With both L shapes prepped, it's time to bring them together and close the box. To ensure vertical alignment of the joints, I'm using a framing square. The trick here is to look at the light under the gap of the edge of the square. If the light shines through unevenly, the face is leaning. At that exact same time, I'm running my fingers across the outside edges to make sure the two sub-assemblies are completely flush with one another before locking it down with the clamps. Now, with everything clamped down, I run a taut string line from corner to opposite corner on both sides. How they cross in the center tells us if the tabletop top is on the exact same plane. What we want is for these two strings to occupy the exact same point in space. If they're barely touching and kissing each other, where moving one slightly moves the other, the table is perfectly flat. If there is a gap, or if one line is visibly forcing the other down, the frame is twisted and I need to shim the appropriate corner. Next, I need to check the diagonals to ensure I won't be welding the table in the shape of a diamond. In my case, one side is slightly longer than the other, so I hook up a ratchet strap and pull on the long diagonal until both cross measurements read exactly the same. With the frame square, I check the crossed string lines one last time to make sure the table hasn't twisted out of plane.
Now that the table is perfectly square, perfectly flat, we can go ahead and tack the two remaining corners and run beads across the tops of each joint, and with any luck, the table will still be flat.
Look at that string line. That right there is true level. Somewhere out there, a machinist is looking at this and crying tears of pure joy. Next up, I'm prepping the inner cross members to slide them into the frame. Do yourself a massive favor if you're building yourself a chassis table. Cut the inner cross members just a fraction short. Otherwise, you're gonna struggle exactly like I did. Once the members are forced in, I bring back the framing square to check the light gaps, align the crossbeam to the rails, and tack it all down. Then it's just a matter of repeating the process for the rest of the layout. If you're looking at building a chassis table for yourself, I want to reiterate, you don't need to use stock this heavy. You can get away with 2x3 by 1/8 inch box section, assuming you have enough feet to the ground to keep that chassis table flat. With all the cross members in place, I run heavy beads across the top of each joint, locking this structure in for good. Now, I need to flip this entire table over to weld the underside because I absolutely refuse to weld overhead. But in case it hasn't sunk in yet, this thing is incredibly heavy. I grabbed a pipe for leverage and the table just laughed and bent that immediately. Plan B. Using the floor jack, I start lifting the chassis table and propping it up with whatever random wood offcuts I can find on the shop floor. I was making great progress at flipping this thing over, then things began to get sketchy. I'm sure most of you can already see exactly what's about to happen. Well, that happened. But since the table clearly refuses to be flipped right now,
I'm going to change focus and begin working on the legs. And that's going to require 3 pieces cut out of this box section. First piece we have here with 1 captive nut. Second piece we have here with 2 captive nuts. And third we have the leg itself.
I start by laying out the leg design and making the primary cuts with a skill saw. But to get into the tight corners without cutting past my lines, I switched to an old fabricator trick, using a well-spent, tiny cutoff wheel on the grinder. The smaller radius lets you get deep into the cut without chewing into the material you want to keep. With the main legs done, I can cut the smaller parts from the offcut. Just like before when welding the main rails end to end, I need to bevel the bottom of the table leg to make room for a deep, high penetration weld bead. Next, I need to bore a hole large enough for the captive nuts. A quick pilot hole sets the path, and a step bit makes quick work of opening it up to size. To get a perfectly snug fit, I bored the hole just a hair smaller than the nut itself and use a bench vise as a press to force it into the steel. Since the captive nuts are going to be bearing the weight of the entire finished table, a press fit isn't enough. I'm locking them down for good with a couple of solid spot welds on both sides. The last piece gets the exact same treatment. Rinse and repeat the layout, drilling, and press fitting to get our last set of captive nuts locked in. Now I can lock down the whole assembly together and grind the welds back for a smooth finish. And here is the reason for all this complexity in a simple part. Since I work in a tight 2-car garage, floor space is at a premium. I need this table to be completely mobile, but also rock solid when I'm actively working on the chassis. By creating this stepped leg design, I get the best of both worlds. Heavy duty casters for moving, and massive leveling feet for locking it down. If you want to pick up a set of your own, links in the doobly-doo. Finally, I can tack the legs onto the chassis table and test out the mobility. One push and this massive frame glides effortlessly. Absolutely buttery smooth. And just like that, the mobile chassis table is officially a reality. Despite the heavy steel, the battles with warping, and almost losing my shins to a sketchy floor jack incident, we got it done. Honestly, looking at how flat this surface turned out, I might just drag a mattress out here and sleep on it tonight. True level is a beautiful thing. Now that we have a perfectly flat foundation, it's time to bring JoJo back into the garage and begin the actual chassis fabrication. If you like this type of content, hit that like button, subscribe, and a big thanks for watching, and I'll catch you in the next one. Peace!